when you do the fundamental theorem of calculus, a derivative and an integral cancel each other, but you have to replace your variable. So like on the y equals integral of 1 to sine x 5 minus 3t squared dt. If I said give me the derivative of that, you could integrate it and then do the derivative. Or you could recognize the derivative and an integral cancel each other. But what's going to happen is your t gets replaced with the sine. But you also have to do the chain rule. If this isn't just a plain x, you have to do times the derivative of that. So the derivative of sine is cosine. So remember fundamental theorem of calculus has to go from a constant up to x. If it's not an x, you have to do the chain rule. Like if it's from x to 1, to flip those limits, what do you have to put in front? A negative. So like on b there, you had to put a negative on that because it started at x instead of the constant. So that 5354 quiz. Any questions you want me to go over there? Let's look at yesterday's quiz. The substitution. What do we need to talk about?
Can you just do the...
Yes. Okay. A few of you made your u t squared, and some of you did t squared over 2. You can do it either way, but you have to make sure that your work supports it. If I only make my u the t squared, then when I do the derivative of that thing, I'm going to have to end up doing a chain rule. I'm going to make my u the entire inside, so I'm going to say u is t squared over 2. du. You're not just making up a du. It's the derivative of this. So the 2 comes down, the 2 on top and bottom would cancel, subtract 1 from the power, so we just get t dt. So if I'm looking, the t squared over 2 gets replaced with my u. That's not what I wanted to do. My t dt is going to become my du. You'd have to get rid of all of the t's, which we do when we plug that in. So if you want to change your limits. Now, a couple things. If you don't change your limits, you have to plug the t back in at the end. If you change these limits, just keep it in terms of u, because these are the numbers for u, so we're going to plug them in for the u. So if I put in a 0, 0 squared over 2 is 0. If I put in the square root of pi squared is pi over 2. This would become sine of u, and the t dt just gets replaced with a du. Is everybody with me there? So integrate. The antiderivative of sine is negative cosine. The derivative of cosine is negative sine. From 0 to pi over 2. Since I changed these limits to match my u, I can just plug them in now. So we have a negative cosine of pi over 2 minus a negative cosine of 0. So cosine of pi over 2, it's like cosine of 90 degrees. Think about your unit circle. Cosine is the x, so that would be a 0. Minus a negative, so plus cosine of 0 is 1. So we get 1 for our answer. What else? I want to talk about C real quick. This problem kind of made it obvious to me that some of you aren't paying attention when you do your DUs. You're just writing down something from the problem and not actually working the derivative. Some of you set your u to be sine to the 5th of 3z. That means sine of 3z to the 5th power. if you do that, your du is the derivative of this. So what happens when you do this derivative? 5 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, derivative of sine is cosine, angle stays the same, times the derivative of the angle. Do I need all of that stuff? No, you don't have anywhere to go with it. We only had a sine to the 5th. I don't need this sine to the 4th. So that is a big red flag that there's an issue with my u. Go back and take away the 5th power. So if your u is only the sine of 3z, then your derivative of sine is cosine, angle stays the same, but derivative of the inside, derivative of 3z is 3, and we have our dz. So look at your problem. You have a sine of 3z, which will replace with the u. We have a cosine 3z dz. So do I need that 3? So you divide that over. So that means 1/3 du is the cosine of 3z dz. A lot of you did not have that 3 from your chain rule. So then when I plug this in, the sine to the 5th becomes u to the 5th. The cosine 3z dz gets replaced with my 1/3 du. So your antiderivative, just bring down your 1/3, add 1 to your power, so that's u to the 6th. So you need the reciprocal in front, which is 1/6. So we get 1/18. We have to replace our u. That was sine of 3z to the 6th, so you can put this in parentheses with the 6 on the outside, or sine to the 6th plus c. Does that make sense to everybody? Anything else on this quiz that we need to look at? You guys didn't do bad, but there were a lot more errors, just little dropping coefficients and things than usual. So I want to make sure we're okay with that before we move on. Okay. Then if you would just set those in the corner of your desk, I will collect them back. Let's take a look at our study guide. So this is only over 3 sections, and actually I just gave you back both quizzes from those 3 sections, so we should have a pretty good idea of the type of stuff on this quiz, or on this test. Let's make a list of your questions. So number 1, the derivative of that should be 2x times x to the 4th plus 1 squared. Number 2 should be 4 cosine of 64x cubed. We okay with both of those? Do I need to discuss them? Yeah.
Do you want us to multiply the cube throughout, or can we just leave it 4x cubed?
You could also write it like this. Either of those is fine. Okay. Let's talk about number 3. So I told you that g of x is the integral of f of t. And in the problem I told you that f of t is the square root of t squared plus 4. Then I ask you to find g prime of x, and we're on the interval 0 to x cubed. So g prime of x, all I'm asking is the derivative of the integral. So that is the fundamental theorem of calculus. The derivative and an integral cancel each other. As long as you are going from a number to a variable, we just have to plug in our variable. Times, what's the derivative of x cubed? 3x squared. So we should get 3x squared times the square root of x to the 6th plus 4. What if I had gone from x cubed to 0? You do a negative. You can flip your upper and lower limits just by throwing a negative in front of everything. So 1, 2, and 3, those are all fundamental theorem of calculus questions. There'll be a few of those on your test. If you remember what you're doing, it's really simple. You don't have to calculate much of anything. If you don't, you could always work through, do the antiderivative for the integral, and then do the derivative of that, and you will get to the same answer. Right, number 4. Find the total area between the x cubed minus 2x squared minus 15x and the x-axis. So we have talked about an integral being area between the curve and the axis, right? If I say it like this, the total area, then I am talking about absolute value. We know that in general, if you have a curve like this, this is a positive and this is a negative, and so they would cancel each other out. But when I say total area, remember that's like talking about absolute value of your area. So we have to first find out when this thing hits the axis. So first find out when it is equal to 0. All right, if I do that, what would I need to do first? Take out an x, so that's x squared minus 2x minus 15. Okay, box method, multiply negative 15, add to negative 2 would be a negative 5 and a positive 3. So we get 0, 5, and negative 3. So that means I will have to integrate between all of those. So you'll have to go from negative 3 to 0, and from 0 to 5. Because I want things to be positive, we have to think, okay, if I'm between negative 3 and 0, like if I'm at negative 1, if I plug this in, would I get a positive or a negative answer out? Negative. So how do I make that positive? What am I going to have to do? Run a negative. Does that give me a negative, or does that give me a... That gives me a positive, doesn't it? Because this would be a negative 1 times a negative 6 times a 2. So that's positive. So we don't have to change that one. If I'm between 0 and 5, so if I plug in a positive 1, I get 1 times a negative 4 times a 4. So that one's negative, so we run the negative through to make it a positive. Everybody with me so far? These problems, this would be a high point value question because there's a lot involved here. Finding when it equals 0, setting up the two integrals. Now we need to integrate both of them. So when I do this, antiderivative of x cubed, you add 1 to your power and put the reciprocal in front, minus x squared would go to an x cubed, so I need to multiply by 1/3, so 2/3 x cubed. This would turn into an x squared, so 15 halves x squared from negative 3 to 0. I'm going to go ahead and distribute this negative. So then I would get a negative 1/4 x to the 4th plus 2/3 x cubed minus 15 halves x squared from 0 to 5. Yes, it is. Thank you. Okay. Make sure you're evaluating your integrals correctly. You plug in the upper minus the lower. So if I put in 0, we get 0. Minus if I put in -3, -3 to the fourth would be 81 over 4. -3 cubed is -27 times -2/3 would be a positive 18. -3 squared would be 9. Are you guys checking my math at all? So that's the first one. The second one. If I plug in my 5, we get -625 over 4 plus 5 cubed is 125, 250 over 3 plus 25 times 15 over 2 minus, if you plug in a 0, you get 0. Alright, so obviously on the test, I'm going to give you some nicer numbers. But let's go ahead and figure out what this would give us. So we'd have a -81 over 4 minus an 18 plus 135 over 2 minus 625 over 4 plus 250 over 3. And we get 143.833 for our final answer. Any questions on that? Number 5. So we are looking at the graph here. I'm going to put this up here so I can point at it and talk about it at the same time. Okay. So part A. G of 0 and G of 6. G is the antiderivative of this. So this is F, and it told us that G is the antiderivative. Okay, antiderivatives tell you like area under a curve. This is going from 0 to x. So when I say G of 0, that's saying you have the integral from 0 to 0 of your function. If you start and stop at the same place, how much area is under your curve? 0. So part A, your G of 0 is 0. Part B, or second question on A, I asked for G of 6. So that's like the integral from 0 to 6 of this. So we're adding up all the area from here to here. Keep in mind, this would be positive and this would be negative. So what do those do? They cancel each other. It's the same amount on both of them. So if they cancel, we get 0 again. Part B. Estimate G of x for each of these. So that is just our area under the curve. So the first one was G of 1. So it's saying starting at 0 and ending at 1. So if I want to add up these, that's 1, 2, and a little more. So what would you call it? 2.8-ish? Okay. Then second one I asked for x equals 2. So we're already at 2.8. So this would take me to 3.8. And then I add up, another little bit. What do you want to call that one? We've got 4.75-ish. Okay, then we keep adding in. So add in this little box, that would probably make this a full one. And that one, so now we're at approximately 5.25, 5.35, somewhere around there. Do you guys see how I'm getting these? Okay, so now when we add in a 4, so we're at like 5.35. If I add in a 4, now I'm going to start subtracting stuff off. So here you're going to subtract off, looks like a little more than half of a box, so maybe subtract off 0.6 or something like that. And we get 4.75-ish, somewhere in the ballpark there. G of 5, so now we're subtracting off even more. We have not quite 2 full boxes, so somewhere around 2.8, something like that. As long as you are in the ballpark with those, that's okay. I just want you to understand, if you're looking at that graph, that interval is the area under the curve. Above is positive, below is negative. Is that one okay with everyone? Okay, C. On what interval is our graph increasing? Okay, so I want to know when G would be increasing. So you can look at it 2 ways. If you look at the numbers, we can see pretty clearly that my G was going up until I got to 3, and then it started going down. If you think about this, f of t was positive until it got to 0, and then it became negative. So increasing, then decreasing. So it's increasing from 0 to 3. Your maximum, so 3, you were increasing before then, decreasing afterwards, so you have a maximum when your x is equal to 3. Then sketching the graph, you can plot the points that you have from part B. So if you plot all those, we see that curve. Okay. So the next ones, you guys did not ask about anything on this page, but I want to give you the answers, and if you miss any of them, I would like to work them out, if that's okay. So number 6, you should get negative 1 over 16 cosine of 4x to the 4th plus c. Number 7, 1 over 2 pi sine 2 pi x plus 2 plus c. 8, 52 over 9, 9 is 0, 10 is 3/2 plus the natural log of 2, 11 is 4/3, 12, 1/3 x cubed, minus x to the negative 1 plus c, 13, 1/6 v to the 6th plus v to the 4th plus 2v squared plus c, 14, 1/3 x cubed minus 4x to the 1/2 plus c, 15, negative cosine t minus 2 e to the t plus c, 16, 1/3 natural log of z cubed plus 1 plus c, 17, negative 2/3 cosine of 1 plus x to the 3/2 plus c. And we asked about 18, so we'll work that, but if you guys miss any of these, mark them, and then if we have time after we get through the questions you already asked, we'll go back to those, okay? So problem 18, we have the integral of e to the cosine t times sine t dt. So some of these problems we need substitution and some we do not. Looking through, you need substitution on something like question number 6, 8, 9, when you have variables multiplied together and we can't simplify. You know, question number 10, you have u in multiple places, but you could split it up and do individual terms. 11, we could FOIL those out, so we don't have to do substitution on all of these problems. On this one, when I'm looking at it, I have multiple t's, and there is no way I can combine those, so that tells me substitution. You want to let u be the most complex one. Now, sine and cosine, there's not much difference, but this one's in the exponent, so that's definitely what I want for my u. So u is cosine t. du, derivative of cosine, is negative sine t dt. Again, I can't stress this enough. Your du is just the derivative of that. You're not looking at your problem and trying to guess what else you need. It's just your derivative. Alright, if I'm looking, I don't need the negative, I only need the sine t dt. So if I divide my negative over a negative du, we'll replace the sine t dt. So we have the integral e cosine t becomes a u. This other step is negative du, so I'm just going to throw the negative in front. Alright, antiderivative of e to a power is e to the power. So we still have a negative e to the u plus c. So final step, replace your u. So that's negative e to the cosine t plus c. Number 19, you should have gotten 1/2 minus 1 over 2e. Different ways you could write that. You could have like 1/2 times 1 minus e to the negative 1. That's equivalent. Problem number 20, you should get 10 over 3. 21 we asked about. Okay, is there any way I can simplify this from the beginning? No, because I have more than one term under the radical. So when I'm looking at these, I have to pick my u. I don't want to have like a du under the square root, so the thing under the square root has to be my u. So du, the derivative of that would be 2x dx. So 1/2 du will replace my x dx. Okay, let's take a second and look at this. This one's kind of a little more tricky. My square root is like a 1/2 power. We know that x dx will get replaced with something, but I had x cubed. So I'm going to separate my x cubed into an x squared and an x for a moment. Okay, I just rewrote the problem to illustrate what's going on. The x squared plus 1 to the 1/2, that would become u to the 1/2. X dx is 1/2 du. What am I going to do about this x squared? Solve for it. That means u minus 1 is equal to x squared. Okay, if I change my limits, if I plug in a 0, 0 squared plus 1 is 1. If I plug in a 1, 1 squared plus 1 is 2. So this is the integral from 1 to 2. The 1/2 is just coefficient, so if you'd like, you can pull that all the way out. If you distribute, u times u to the 1/2 is u to the 3/2 minus u to the 1/2 d. So now we do our antiderivative. Add 1 to the power, so that's 5/2, put the reciprocal in front, 2/5. Minus, add 1 to your power, so that's 3/2, reciprocal in front, so that's a 2/3. Since I changed my limits, I don't have to plug back in my x. We're just going to put in the 1 and the 2 here. So we have 1/2. Okay, if I put in my 2, minus, if we put in our 1, we just get a 2/5 minus 2/3. Okay, not a very nice problem here, because this means the square root of 2 to the 5th. So on a test, I would give you something that you could evaluate the square root of, so you'd be putting in like a 1 or a 4 or a 9, something that we could work with. So let's just use our calculators to finish this one off, since it's not going to come out pretty anyway. I'm sorry, it's hard to make all these problems come out nice, so I usually put my effort into making the test nice and not the study guide. And you should get 0.3219 when you do that. That one was pretty ugly. Let's take a look at the rest of these. So number 22 tells us the model for the basal metabolism rate in kilocalories per hour of a young man is this equation. T is time in hours. What's the total basal metabolism over a 24-hour period? So this is the rate. If I want the total amount, what are you going to have to do to your rate? Integrate. A rate is a derivative, so if I want the amount, you have to do the antiderivative. T is in hours, and we want a 24-hour period, so we'll integrate from 0 to 24. Okay, derivative of 85, or antiderivative of 85 would be 85t. Minus, we have the 0.18. Antiderivative of cosine is sine. The angle would stay the same. But you would have to do the chain rule. What's the derivative of this angle? Pi over 12. So you have to put the reciprocal in front, so that would be a 12 over pi in front. So again, probably not the nicest numbers. So 85 times 24 is 2040 minus would be a 2.16 over pi sine 24 pi over 12 would be a 2 pi minus, if you put in 0, you get 0 minus 2.16 pi over pi sine of 0. 2 pi and 0 are at the same spot. On the unit circle, sine is your y. What's the value there? 0. So you get 2040 minus 0 minus 0. So our answer is 2040. Okay. Problem number 23. So water flows at the rate of 200 minus 4t liters per minute, where t is between 0 and 50. Find the amount of water that flows from the tank in the first 10 minutes. So what am I going to integrate from? 0 to 10 of the 200 minus 4t. So antiderivative of 200 would be 200t, minus the antiderivative of 4t would be a 2t squared. This is one that we can easily do by hand. If you plug in your 10, you get 2,000, minus 10 squared is 100, so minus 200, minus, if you put in a 0, you just get 0. So we have 1,800 and we were in liters. A bacteria population is 4,000 at time t equals 0, and the rate of growth is 1,000 times 2 to the t bacteria per hour after t hours. What's the population after 1 hour? Okay, this one has a few more tricks to it. Population, so we have to integrate. We're starting at 0 and t was in hours, so we'll just integrate from 0 to 1. Okay, so if we do this, antiderivative of e to the t, or of 2 to the t, you have to think for a minute. If you remember when we did the derivative of these exponentials, if it wasn't a base of e, you had to add in a natural log. So like if you had 2 to the t, the derivative of that was still 2 to the t, but times the natural log of 2. So the antiderivative of 2 to the t is still the 2 to the t, but what would I have to multiply by to cancel the natural log of 2? 1 over the natural log of 2. That's why we like the e's so much, because we get to leave that part off. Okay, so if we plug that in, 2 to the first is 2, so you get 2,000 divided by the natural log of 2, minus, if you plug in 0, 2 to the 0 is 1, okay, so this tells you 1,000, we would probably round to the nearest whole number because we're talking about a population. You can't have a partial one. But this is not the correct answer. I asked for the population after 1 hour. That represents the amount the population has changed. So we have added 1,443. But how many did we start with? 4,000. So if you add your 4,000 to that, we get 5,443 bacteria. I put several of those word problems on there. Your test, I'm not going to have a ton of those, probably like 2-ish. One, probably just interpreting the meaning, so I want to understand that if you're doing an antiderivative, you're getting an amount. So if I give you, the antiderivative of the marginal cost. Marginal cost is how the cost is changing, so the antiderivative would give you the actual change in cost. If I give you a population, population growth, the antiderivative is the amount the population has changed. So I probably, I always put some multiple choice questions on there, so you could probably expect one multiple choice question, just do you understand what an antiderivative does? It goes from a rate back to an amount.
So when you did the antiderivative of the problem here, why didn't it be 1,000 change to 1,000 t?
Because it's not added. It was multiplied, so it's just a coefficient. So when we do the antiderivative, coefficients just trail along. So then the very last question on here was question number 25. Just one of those, what does it mean? So you'll probably have one of those, and then one like the 22, 23, 24, where we actually calculate it. So on 25, your R is the rate, so the antiderivative would be the gallons of oil that have leaked in the first 120 minutes. Okay. So that is not the majority of your test. I just put several on there because I know we need to practice those a little bit more. Are there any other questions that you want me to go over? 19. Okay, is this one that I can get rid of the product without doing substitution? No. So we have to do substitution. So we want to make our u the most complicated part, which is definitely always going to be your exponent if you have one. So your du would be a negative 2x dx. We only need the x and the dx, so negative 1/2 du is x dx. So we're going to integrate. If I put in a 0, negative 0 squared is 0. Put in a 1, negative 1 squared is negative 1. Of negative 1/2 e to the u du. Okay, you guys with me there? So the antiderivative of e to a power is still e to the power. So we have a negative 1/2 e to the negative 1 minus e to the 0. Different ways you could write this from here. E to the negative 1 just means 1 over e. E to the 0 is 1. So you could leave it like that. On mine I distributed, so that's negative 1 over 2e plus 1/2. Anything else? You want me to just make up a problem? You want a hard one? What if I said you have the integral of, let's say 6e to the 3x over 2e to the 3x minus 4 dx. Okay, is this one that we can do the antiderivative of without doing substitution? No. So, what would you make your u? I would probably just, you could do it a couple different ways. If you only make it the exponent, you're still going to have variables on top and bottom. You'll have an e to the u over an e to the u. So it's not going to totally get rid of it. So let's just make it the entire denominator and see what happens. Substitution, sometimes you might try something and it doesn't work, so you try a different substitution. So derivative of e to a power is still e to that power, but you have to do the chain rule. Times the derivative of the exponent, which is 3, times that 2 gives us a 6. Derivative of 4 is 0 dx. So we are in really good shape here because the denominator can become the u, and the 6 e to the 3x dx is all my du. So we have the integral of 1 over u du. What's the antiderivative of 1 over u? Natural log of u plus c. So that's the natural log of 2 e to the 3x minus 4 plus c. I have 2 minutes. Can I do one more? Do I need substitution on this one? Do you guys see the difference between the last problem when I had to do substitution and this one where I don't? Because on the last one you had 2 terms on the bottom, so you couldn't do anything. Since there's only 1 term on the bottom, we can split this up. That's like an x to the 1/2. So don't make life harder than it has to be. If you can simplify first, do that. So when you divide, you subtract exponents, so that's 3x to the 3/2 plus 5x to the -1/2. So if we add 1 to our power, that's a 5/2, so we need a 2/5 in front. So become x to the positive 1/2, so you need a 2 in front, plus c. So you get 6/5 x to the 5/2 plus 10x to the 1/2 plus c. So not necessarily a lot of material on here, but make sure you're reviewing and come see me